Welcome to the tutorial on DGX Cloud MultiNode Jobs. In this tutorial, we'll do an overview of MultiNode Jobs, and then we'll show examples of running MultiNode Jobs using the web interface and the command line interface. Finally, we'll give an example of using Jupyter Lab. Let's start with an overview of MultiNode Jobs. One of the advantages of NVIDIA DGX Cloud is to be able to run jobs across multiple nodes that each has 8 GPUs. When running a multi-node job, NVIDIA-based command platform reserves all nodes as specified by the replicas option. The nodes are networked together and to storage through high-speed fabrics. The specified command line in the job definition is executed only on the parent node, which is identified by replica ID 0. It is the responsibility of the user to execute commands on child nodes, which can be done with MPI run or BCP run commands. Outside of these factors, running a multi-node job is very similar to running a single node job. Let's take a look at the basics of running a job. In the left-hand menu, click Base Command, then click Dashboard. A new job can be created by clicking the Create Job button. You can also check on and create jobs by clicking on the Jobs menu on the left. Here, you'll see a list of running and completed jobs. To create a new job from here, you can click the green Create Job button in the upper right. On the Create Job screen, you'll see the option for single node, multi-node, and templates. The Accelerated Computing Environment, or ACE, is where jobs are run. This will be unique to your organization. If your organization has more than one ACE, the administrator can tell you which ACE to use for your jobs. The instances available are filtered by ACE, and the names may differ by ACE. An instance is selected to run a job on. For multi-node jobs, the multi-node type and replica count must be selected. MPI is the legacy array type for NGC jobs to launch multi-node applications from a single launcher. PyTorch will set the environment to launch distributed PyTorch applications with a simple command. The replica count is how many nodes the job will run on. The minimum is 2. Datasets are read-only artifacts that can be mounted to a job by clicking the checkbox near the dataset. You must also include a unique mount point for each dataset added. Workspaces can be added as read-write or read-only by using the toggle switch. Datasets and workspaces are optional for each job. The next section is data output. A result mount point must be added to each job for writing logs and other data from the job. To learn more about data management, please watch the DGX Cloud data management videos. In the next section, we select the container that we are going to run. The containers in the drop-down list are based on your access. If you know the name of the container, you can type it into the box. After the container is selected, the related tag must be chosen. The run command is the command that will run inside the container. Information on building a command can be found on the overview page for the container. If a tool in the container needs to be accessed externally, the port protocol and port number can be added. The job priority can be set to low, normal, or high. High priority jobs will be run first. The job order is a number from 1 to 99, where lower number jobs run first. In the Launch Job section, you can select a name for the job. The preemption options are run once and resumable. Run once is the default condition and specifies that the job will not be restarted if preempted. Resumable allows the job to resume where it left off after preemption, using the same command that started the job. The total runtime is how long a job should run in seconds. The time slice is the minimum amount of time a job should be allowed to run if it is set as resumable. This is also in seconds. Custom labels can be used on a job to help identify it. Finally, the black box at the bottom is the equivalent CLI command for the job that has been built. This can be copied to run the job from the CLI in the future. Once all of the required information is input, the Launch Job button in the upper right-hand corner will become green and it can be clicked. The Templates tab includes templates for jobs. If you want to use a template, click the three dots and click Apply Template. All of the information for the job will be auto-populated and the job can be run as is or updates can be made. From the Jobs page, we can click on a job to get more information about a specific job. The Overview page gives information on how many GPUs are being run, the command that we're running, any map ports, and data mounts. The Telemetry page shows statistics on the job and GPU utilization. The Status History tells us the status of the job at any given time, from when it's created to when it stops. The Results tab is where outputs from the job can be seen. The Log tab is where you'll see logs for the job. Now, let's run a multi-node job. To start, we'll click Base Command in the left menu, and then we'll click Dashboard. From the dashboard screen, we can click Create Job. At the top, we'll click Multi-Node because we're building a multi-node job. We select our accelerated computing environment. Because this is a multi-node job, we only have one instance available, which uses all 8 GPUs. Next, we pick PyTorch for our multi-node communication type, and we select 2 for our replica count. We'll add the edu_ds dataset, and we'll add that at the mount point /edu_ds. We'll also add a couple of workspaces. We'll add edu_workspace as rewrite at the location /edu_workspace. We'll also mount translated AI workspace as read-only at the mount point /AI workspace. For our output, we'll use /results. For our container, we'll use PyTorch. Again, we can search for that, and then we'll select NVIDIA PyTorch, and we'll use the latest version of that container. We'll paste in our command, and we'll open up port 8888 because we'll be using the Jupyter Lab, which listens on port 8888. We'll add that port. If you need to delete a port, you can click the red icon to delete that port. We'll update the name to edu_multinode. We'll keep the preemption options the same as run once, and we'll update the time to be 600 seconds or 10 minutes. We'll add a couple labels to the job. We'll use demo and edu_test. Remember that the CLI command can be copied by clicking the green icon on the right side of the black box. Now, we can launch the job by clicking the green button in the upper right corner. Once the job is starting, we'll return to the jobs list. We can click the job name in the list to get more information about the job. On the Status History tab, we can see information about this job. For example, this job is starting. To the left, we can also see that we have markers for the overall job, replica 0, and replica 1. These represent the 2 nodes that this multi-node job will be running on. The Overview tab shows us the command that we're running, the map ports, and the datasets and workspaces that are mapped to this job. Clicking the URL in the map ports section will get us to the Jupyter Lab. Now let's take a look at running a similar job using the command line interface. We copied the job from the web interface and modified it slightly for readability. We'll paste the job into the command line and point out a few things. Most of the information is similar to what we use in the web interface. In this case, we're able to put in our runtime in minutes versus seconds, and also note that for the dataset and the workspace, we have to have their IDs to mount them to the job. With the workspaces, we also have to give RW for a read-write or RO for a read-only workspace. When the job begins, we want to make sure we take note of the job ID. This will be useful to get information on the job later, such as the link for the Jupyter Lab. To get detailed information on this job, we use ngc batch info with the job ID. Now let's see an example of how to use Jupyter Lab with MultiNode Jobs. Now we're in the Jupyter Lab. We'll go to the terminal, and then we'll go to the directory of one of our workspaces, in this case, edu_workspace. We'll use bcp run to run a script in this directory. The inputs are based on environment variables that are part of our setup for this MultiNode job. This script will be run on both of the nodes in this job. As that script runs, we can go back to Base Command Platform to look at telemetry and other statistics related to this job. We can see GPU time active, GPU utilization, and how long the job's been running. The default information is an average across all nodes, but using the drop-down menu, we can see this information for each specific node in the job. This concludes our tutorial on running MultiNode jobs on DGX Cloud. To get the latest information on DGX Cloud and more details on what we've covered here, click the link to the user guide in the description below. Thank you.